Here we have another chain rule that's twice again. I'm going to just put the 4 out there for now. So if you imagine going from the outside in, the first function that you run into is the power of 4. Then inside you run into a tan, and then inside of that you run into 2x. So that's why the chain rule is going to happen more than once. So when we do the derivative, the 4 is going to come out in front. This is going to stay the same. That's your first derivative. Now inside was tan. The derivative of tan is secant squared. And then inside of tan is 2x, and the derivative of 2x is 2. So now if we want to rewrite this, we'll have 8 tan cubed of 2x times secant squared of 2x. Do you want to try one with like a chain rule, like 5 times, 8 times? Is like 2 times chain rule enough? You want to do one that's a function inside of a function inside of a function inside of a function, just to see what it looks like? Okay, let's see what we can make up. Pick a trig function. Secant. You want to get really nasty. Okay. Secant. What's going to be inside secant? Cotangent. Oh man, what's going to be inside of that? Cosecant. How about a cosecant to the power 4? What's going to be inside of that? 1. Yeah, okay, perfect. I like this, okay? The derivative is 0. We're good. We're done. Because it's just a number. We're not putting e to the x because you haven't learned that yet. Okay, we'll do one more. What's the last one? Just a normal tangent. And then inside the tangent, okay, I'll close that one, I'll close that one, and x cubed. Perfect. Okay. Now, this is my function y. Because this 4 is going to confuse us being in there, let's secant, bracket, cotangent, bracket, cosecant, bracket. Oh, I'm going to go back to blue here. Tan x cubed, bracket, green bracket to the 4. Are you okay with that, putting that 4 out like that? And then I'll close this blue bracket. Just so that when we go from our outside in, we hit that 4 at the right time. Because if we didn't, we might hit it too soon. So, all right, here we go. Working from the outside in. The first function is secant. What is the derivative of secant? Of course, it's on the next page, right? We're gonna pretend we know these for this. This is going to be super long. Thanks for picking secant and cotangent, especially because... Yes. So the derivative of secant is secant tan. So you would start by writing secant. There's advantages to the computer here. Oh, okay, I need to check that out. Okay, good. Good. Oh, yeah. So that would just go inside of there. Okay. Times by, because it's secant, times by tan. And then this would go inside of there. Make that a little bit smaller. It's a little bit big. Oh, that's prettier. Close that up. Times by. Okay, we did the first one from the outside. It'll get shorter every time. Yes. Now I'm going to take this. The next one on the inside is the 4, right? So I'm going to, oops, just a second. Select these. Copy that. And so the 4 would come out in front. Times by all of this to the power of 3. That's our next function. Times by, what's the next one on the inside? So now we've done the secant. And it's almost as if you go back to the original one and you sort of check them off, you won't get as lost as you go along. So we've done the secant. We've done the power of 4. The next one is the cotangent. So, let me just, what is the derivative of cotangent? The derivative of cotangent is negative cosecant squared. So now we'd multiply by a negative cosecant squared of, and everything that's inside the cotangent, which is cosecant times tan x cubed. Oh, too many brackets. Would still be there. So now we've done the cotangent. What's inside? Cosecant. Of course, you had to go and pick all those ones. Oops. The derivative of cosecant is negative cosecant tangent. Negative cosecant, what was inside of the cosecant? Just tangent x cubed. Cotangent of tangent x cubed. Times by, someone's graphed it. Okay, keep it on there. We'll put it on in the end. All right. Multiplied by, now we've done, if I go back to my original one, I have now completed the cosecant. The next function would be the tan. Derivative of tan, secant squared of x cubed multiplied by 3x squared. And we have, someone has graphed this. Is this the derivative?
No, it's the original.
This is the original function, which I think when you see this, this will make a lot more sense. Obviously, when we look at the original graph here, we can now totally understand what's happening. There, oh, sorry, it was blurry. There we go.